Hello and welcome back. Okay, so let's now talk about the second subcategory of machine learning. And of course, it also implies that it's a subcategory of deep learning as well. So this is unsupervised learning, which is in contrast to supervised learning, does not use any labels or targets. So we don't have any feedback here as well. And it's more about finding a hidden structure in the data. So in that sense, we can also think of unsupervised learning as representation learning. And this is sometimes also used for dimensionality reduction. It doesn't have to be used for dimensionality reduction, but it's just one application of it. So you probably have heard of principal component analysis and other statistics classes, or you can say in short PCA, which is a linear transformation technique that rotates the data and then extracts a linear combination of the inputs. So if you consider this example here, there are two features, feature 1 and feature 2, and these are our inputs, and here these circles represent our data points in this space. And with principal component analysis, we find the eigenvectors of this dataset. So in that way, we use these eigenvectors to rotate the data. So we have these two principal components. These are essentially eigenvectors, and usually we sort them by decreasing order, so that we sort them by the eigenvalues by the corresponding eigenvalues. So we usually keep the large eigenvalues or the eigenvectors corresponding to the large eigenvalues. So in this case on sorry so in this case, on the eigenvalues corresponding to the first principal component is larger than the second one. So in practical application, we may use this first principal component to have a compressed representation of our data. But this is a little bit more detailed than we need to know. I just wanted to show you an example of unsupervised learning. So here it was. If you don't know how PCA works, no worries about that. It's just if you know it, this is a nice example of unsupervised learning. So another example of unsupervised learning are autoencoders. So autoencoders works like this. It's actually a very simple concept. You have the input data. So here this is your input data, and then you have the output produced by the autoencoder. And the autoencoder consists of two parts, an encoder and a decoder. And first, the dimensionality of the input is very large, and then through hidden layers there are that's a learned representation that is smaller, that is in smaller dimension. So we call that also the latent representation, or feature embedding, you can say. This is let's say low dimensional autoencoder, and this is high dimensional, which is at the input side. So you can think of each pixel in the image as a feature. So if we have, let's say, 100 times 100 pixels, we have 100,000 features as the input. So in that way, it's a very high dimensional input. And then you can maybe make this like 10 dimensional. Well, it really depends on the dataset. But let's say we make this 10 dimensional. This is learned by the encoder, by the way, and it's a neural network. And then we have a decoder which undoes this, that it's basically the opposite, taking the low dimensional input and making the high dimensional output. Let's say 100,000 dimensional output, which was the original input. So the goal here is reconstructing the input. So you may be wondering, why would we be interested in that? So, and why is that useful exercise? And what's the point of this autoencoder if it's just learning how to reconstruct the input? So the goal is basically what the interesting part is, this latent representation. So you can think of this as a compressed version of your data. So the decoder is able to reconstruct the original image from this small dimension. It means that this dimensionality here is sufficient to encode important information about the data. So it's you can think of it as a compressed version of the data. So in that way, it's also dimensionality reduction. There's actually a close relationship between an autoencoder and principal component analysis. If the autoencoder consists of linear activations, but don't worry about this detail. We will be talking about autoencoders more in the later videos. It's just another example of unsupervised learning here. And just for reference again, how classification works is the majority of deep learning is about classification. So consider we have an input data point here. It's this cat image, and during training we have a label that's a cat here, that it's a cat here, and then the network produces the probability that this image is a cat, and then we can give it a new data. It could be a dog or a cat, and basically well, it can be anything, and then it would produce a probability that how likely it is to belong to class cat, for example. So a classifier is classifying the image, what label they have, whereas unsupervised learning is really very different. It's not about predicting any labels here. It's about learning this hidden representation that can be used to reconstruct the input. Okay, so this was one of the example of unsupervised learning, the dimensionality reduction or representation learning. Another example of unsupervised learning is clustering. You have probably heard of clustering before. It's assigning a group membership to unlabeled examples. So here let's consider a data set where I have again two features, x1 and x2. I don't have any class labels. I'm just grouping them by similarity, and just by looking at it you can think of these points here because they are closer together that they may belong to a cluster, and these belongs to a cluster and so forth. Here it's kind of obvious what belongs to a cluster. In real life, however, cluster boundaries are sometimes not so clear. It's also usually high dimensionality. So usually clustering is about finding group memberships. So yeah, but here the difference again to classification is that we don't know the true labels. So we can also say that this could maybe one cluster and this could be one cluster. There are some measures for measuring the cluster quality, like intrinsic measures, but we don't have like a real true answer here. So we won't be talking about clustering in this course as well. It's really not the goal of this course, and it's more like a data mining topic, I would rather say. So in the next video, let me briefly talk about reinforcement learning.